Very good morning, students. Today we are going to discuss about problems based on mesh analysis. In this one, write mesh equation and find current flowing through 8 ohm resistor. So this is a 8 ohm resistor, current flowing through this resistor. We are going to find it out. So here we have the two loops. Always we used to assume the current direction in clockwise. So current flowing through this loop is I1 and current flowing through this loop is I2. So to write the KVL equation now, we need to check all the sources are voltage source or not. Now in this problem it is given as all the source as voltage source. So first let us confirm with that one. Second thing, so current always flow from higher potential to lower potential, correct? So when you see here, the current direction will be like this, correct? So if you find current flow in this through the source, so we can take it as positive voltage, correct? If it is the opposite direction, then we can take it as negative. Okay, we know already to write KVL equation, applying KVL in the loop 1. Okay, so for loop 1, the KVL equation is sum of the algebraic sum of the potential rises is equal to sum of potential drops, correct? So in this loop we have two potential rises. We have to consider whether it is positive or negative. First one, see, we have considered this direction, so it is as we specified here already, correct? So we will take this as plus 15, correct? Then we find another source also, so whether it is to be subtracted or added. So if you have two sources connected like this and flow of current is like this, we will be adding the sources. Okay, now it is not like that, the direction is just opposite of what we expected. So shall we put this as minus 15 hence? So this is the algebraic sum of potential rises. Only we have two sources, hence two potential rise, correct, is equal to now potential drops. So this is the 5I1, correct? So 5I1 and then plus another resistor 8 ohm, where the current flow is for this loop here, for this loop current flow is just opposite. So if it is so, we have to subtract the current, correct? So 8, while we consider the first loop, it should be I1 minus I2. If you consider in second loop, it should be I2 minus I1. Okay, then plus 5 and plus 10, correct? Either you can add together or you can write it separately also. So like 5I1, I1 only flows here, here also I1 only flows, 5I1, 10I1. So 0 is equal to 5I1 plus 8, 13, 18 and then 28. So I'll write this as 28I1 minus 8I2, correct? This is my first equation, clear? Now we'll be writing loop 2 equation, correct? So for loop 2, no, see here, for loop 2, okay? So same manner, the sum of the potential rises, we have two potential rise, voltage source, hence two potential rise, correct? So in first case 15 volt, the current direction is like this, hence we will take this as positive, and here it is just opposite of, as I already explained here, no, like this. So shall we put this as plus 15 minus 25? This is the algebraic sum of the potential rises, is equal to potential drops across the resistors, correct? Here 10I2, here 10. So in both the resistors are in series and current flow through this resistor is I2. Hence we can put this as 20I2, correct? Plus current flowing through this 8 ohm resistor, which is between first loop and second loop. As I already told, if you consider in the first loop, you have to put I1 minus I2. If you consider in the second loop, it should be I2 minus I1, as the current flow through the resistor is opposite. If suppose the current flow through the resistor is the same direction, then these currents are to be additive. Okay. Now I expand this. 15 minus 25 is minus 10 is equal to 20I2, so plus 8, correct? So at 28 I2 minus 8 I1, I rewrite this as quotient of I1 and I2. So I'll get minus 8 I1 plus 28 I2. Clear? This is my second equation. Either we can go for the Cramer's rule or just solving the equation using calculator. So as we have the two equations with the two unknowns, it's very easy to solve using the equation mode in the calculator. So I press mode, see here, mode, and then first equation, how many unknowns? We have two unknowns, a1, which is nothing but the quotient of I1, correct? So 28 minus 8, C1 is 0, correct? C1 is 0, and then A2 for this one is minus 8, 28, okay? Minus 8, B2 is plus 28, see here in this equation, plus 28, then C2 is minus 10, okay? Solving this, x value, which is nothing but I1 value, x value or I1 value. I1 is equal to minus 0.11 amps. Then I2 is equal to minus 0.388. So if you round off this one, you will get minus 0.39 amps. Okay. The negative sign in a current indicates that the direction of current is just opposite to that of the what we assumed one. The actual current direction is I1, correct, given as clockwise. Now as I1 value is negative, just opposite to this of assumed direction, okay. And then our aim is to find out current flowing through the 8 ohm resistor, which is I8 ohm as, let us put this as I1 minus I2. I1 is 0.11 minus of minus 0.39, correct? So we'll get this as minus 0.11 minus of minus plus 0.39, okay? So 0.28, we'll get this as 0.28 amps, okay? So we'll solve another problem with the 3 loops where we can apply Cramer's rule, okay, by writing the mesh equations also. Okay, thank you all.